Alright, hi everyone, welcome to my YouTube channel, System Elections. And in this video we'll deal with 1's complement. So we've said something about it in the previous video, I will just continue from here. Okay, so please watch the previous video, like it's super linked to this one. So in 1's complement scheme, an n-bit negative number k is obtained by subtracting its equivalent positive number p from 2 raised to the power n minus 1. Well, this is what we mean here. So, and we said, look at this in the previous video. Where are you? Previous video. That note, negative numbers can be represented in 3 different ways. Negative numbers. So we are dealing with negative numbers. Okay? We are dealing with what? Negative numbers. That is why it said that an n-bit negative number k, that is k is a negative number. Alright, so to get the 1's complement of this negative number, is obtained by subtracting its positive equivalent. So to get the from 2n minus 1, so you do this, say 2 raised to the power n minus 1, then you now put the positive. So this negative number k, to get the equivalent, the 1's complement, okay, to get the 1's complement, you go to its positive. This is a negative number, please. You take its positive, the positive of this number, and you remove that positive from 2 raised to the power n minus 1. I said in the previous video that a complement is what? R minus 1. This is what? Radix complement. R is what? Sorry, R minus 1 is radix, diminished radix complement, and R is what? Radix complement. R is the base. And in this case, we are saying what? 1's complement, because 2 minus 1 is what? 1. So this is 1's complement. For 2's complements, we are just going to have what? We are just going to have what? 2 raised to the power n. Okay? That will be done in the next, maybe in this video if we have the time. Okay? So let's take an example and see. So n is the number of bits, of course. So for example, if n is 4, that means we are dealing with 4 bit numbers. 2 raised to the power 4. If n is 4, we now say k equals what? 2 raised to the power 4 minus 1 minus p. Of course, this will give us what? 16 minus 1 minus p. And that will be what? 15. And this is in base 10, right? It's in base 10 minus p. But of course, 15 in base 2 is what? 15 in base 2. 15 in base 2 will give you 1, 1, 1. Now, to be sure, let me give you a simple way. Or let me a different video for that. Or let's try this. Conversion. I'll make a different video for that. Okay. Or let me just add it in this video to save time. Now, because it's really quick. To convert from base 10, let me put this in 2 columns. Base 10 to 2. Base 2 to 10. Okay? Let me put the line. It's okay. So in this other side, we're going to convert from base 10 to 2. To convert from base 10 to 2, we are using the number 15 right there. So let's continue with that. So base 10, let's convert 15 to base 2. 15. To convert 15 to base 2, 15 is in base 10. We want to change it to base 2. What you have to do, put it at the cross. Put it at the cross. Father! We want to change to base 2, right? You put it 2 here. Now, 2 divide 15. That will give you what? 7, remainder 1. 2 divide 7. That will give you what? 3, remainder what? 1. 2 divide 3, that will give you what? 1 remainder 1. 2 divide 1, or you cannot. So you put that 0 remainder what? 1. So 2 going to 0, 2 going to 1, it will go into 1 0 times. Can't go into that that remainder. So it's going into it 0 times, and this will be the remainder. Since we now have 0, you stop here. Then you do this, you put an arrow, and then you now say 15 in base 10 equals what? You start from bottom, take the numbers 1 1 you write them like that, say 1 1 1 1 in base 2. Answer. This is how you convert any number in base 10 to base 2. Okay, so that is why we have this in base 15 as this. Clear? Now in case you want to switch back, let's say okay, you want to convert from base 2 to base 10. This is base 2. Let me use the same number to make life easy. Same number, base 2. To convert this to base 10, you do this, a very simple approach. This is 1, right? So you now say 1. What is the base? 2. You put this guy times the base. Go to sum to the next thing. 1 is the next thing. Say 1 times, what is the base? 2. Plus the next thing is what? 1 times, what is the next thing? 1 times the base was 2 plus 1 again times 2. So this one for this one. Next one, look at it. Next one, look at it. Next one, look at it. So we have 1 2 3 4. 1 2 3 4. All multiplied by the what? Base 2. Exactly. Then you do this on top. For the back of the head, you put this on top of the base. Start from 0 1 2 3. Okay, so this is what? 1 times what? 8. 2 raised to the power 3 is what? 8 now. Then 1 times 4 plus 1 times 2 plus 1 times 1. This will result in what? 8 plus 4 plus 2 plus 1 equals what? Plus this 12 plus this 14 plus this 15. 15 base 10. Done. Okay, so yeah, that's that. Okay, so I just explained how we do that conversion from base 10 to 2 and from base 2 to 10. So let's come back to our 1's complement. Okay, back to our 1's complement. So we just said that for 1's complement of a negative number, you do this expression, the base raised to the power n minus 1. Then you now minus the positive of that. No, this is a negative number. You minus the positive of the negative number from this thing. And this now, we say for n bits, this n now is what? Example, n is what? 4. So 4. 2 raised to the power 4, that's 16. Minus 1 give you 15. In base 10, 15. Note that when we say complement, the complement arithmetic, we need it in what? Base 2. That's why we did this conversion from 15 to base 2. And I just explained, bonus tip, how we can do from base 10 to 2 and from base 2 to 10. But please, you don't need this in this video. It's just bonus, okay? So we are dealing with complement, 1's complement in this video. Alright, so after doing this now, we can use this expression to solve or to get the 1's complement of a number, of a negative number. Okay, so now let's say 5. Okay, we are looking for 5. So what is the complement of negative 5? Okay, since 5 is a positive number, since 5 is a what? Positive number, that means this place here, this p here, all will be there 5. But 5 in what? Base 2. 5 in what? Base 2. This 111, look at it here. 111 minus 1010. This is 5 in base 2. Not just 5, oh. This is plus 5 in base 2. Because it's 4 bits, I mean 1, 2, 3, 4. And we said for 4 bits, we use 3. This 3 as the magnitude. This left one is the sign, whether it's plus or minus. And if it's 0, is what? Plus. So this is exactly plus 5 in base 2. So, so we minus what? The positive of the number. And this is truly the positive of the number 5. So, minus 5. The complement of minus 5. The 1's complement of minus 5 is what? This 111 minus this number. And that will give you what? This. So this is the 1's complement of what? Minus 5. Make sense? Alright. So similarly, if we want to deal with 3 plus 3, okay, so this is plus 3. So the 1's complement of minus 3 is the 1's complement you are looking for now. You are looking for the 1's complement of minus 3. Remember, we said complement, we are dealing with what? Negative number. For 1's complement, we are dealing with negative number. So the only reason why we just identify plus 3 is because we are going to need this plus 3 to minus from the 2 raised to power n minus 1. According to the definition here, in 1's complement scheme, an n-bit number, negative number, k, in this case, minus 3, and in this case, minus 5, is what? Obtained by subtracting its equivalent positive number, p. So this is a positive number. So, positive number of minus 3 is what? Plus 3. So we are subtracting plus 3 from this guy. And of course, this guy is as a result of what? Doing all this 2n simplification. That's how we got that 1. Okay? So, we will minus the positive 3 from this 1. We are going to get the 1's complement of minus 3. Okay? That's it for 1's complement. Okay? So clearly, the 1's complement can be obtained by simply complementing each bit of the number, including the sign bits. Look at this carefully. Now, if you look at this, to get the 1's complement of minus 5, look at the positive. To get the 1's complement of minus 5, this is the positive of 5, right? Take the complement of the, as in the opposite of each one. Where you have 1, change it to 0. Point. Where you have 0, change it to 1. Point. Where you have 1, change it to 0. Point. Where you have 0, change it to 1. Point. Perfect. Sweet shortcuts. No need for the just change the whole thing. So if I'm looking for the complement of 3 is what? 1's complement of minus 3. Just look at the positive. 3 is what? 1, 0, 1, 1. Invert all of them. This will be what? 0, 0, 0, 1, 1. Done, man. Okay? So, yeah, that's the shortcut there. So I really hope this video helps. And like, share, subscribe, and I'll see you in the next one, which may be the I'll see you in the next one. Okay, so thanks for watching. Like, share, subscribe, and bye for now. Comment also.